All right, so today we're going to be doing 2.4c, which is the last section of 2.4, or I'm sorry, 5.2. Don't know why I said 2.4, of definite integrals. And we're going to be doing calculator and composition today. So if you didn't borrow a graphing calculator on your way in, this is the time to go ahead and grab one of those. So if you don't have a graphing calculator on your desk, go ahead and grab one in the back. Paul, you got one? Graphing calculator? So, I gave you the whole disclaimer about calculators. We will not be allowed to use them on tests, but it's just for practice and understanding purposes of why we're doing it. Before we do anything with the calculator, we're going to do a area composition problem, just like we learned yesterday, but it's just with more things on it. This is the type of question I would definitely give you on a test or quiz. So, we know that the area or the integral evaluated on some interval is always going to be equal to the area of the shape or the graph between the x-axis. That area is going to represent what the integral is. So here we have the positive area.
It's still a trapezoid in a way.
We never said it wasn't a trapezoid.
Well, I'm just saying it is in a way.
And then down below, I'm going to put it in red. Now, why did I do the top in green and the bottom in red?
Negative, positive.
Negative, positive. We know that the area below is going to be subtracted from the top or added negative, same thing. So we're going to have to use composition rules. Now, the bottom one is a true trapezoid, so you could use the trapezoid formula, but I always think it's easier to just do the composition of triangles and rectangles, so that's what I'm going to do. So I have two triangles and a rectangle. Everybody see that?
Yeah. Sure.
What would be the area of this triangle right here?
1/2 base height.
1/2 base height. So 2 times 1, 2, 3 is what?
6.
6. What's 6 divided by 2? -3. Everybody see how I got that area?
Yeah.
That's the formula. A equals 1/2 base times height. Now how would I find the area of this piece?
Length times width.
Length times width or base times height because it's a rectangle. So 1, 2 times 1, 2, 3, that's 6. And then this piece over here. Now I want to mention something. See this upper triangle up here and this lower one? What do you notice about them? They're the same size. Now if you do the math, the area of this comes out to be -3/2 because it's going to be 3 times 1 divided by 2. Yes. You're right, -6, thank you. And this one up here would be 3/2 positive, right? Now, the reason that I mention that is, off the bat, you might notice that we could actually not even calculate those two areas and cancel them out from each other. So, you could go about doing it that way if you want, but I just want to show you, these two areas will cancel each other out. Everybody see why that is?
Mm-hmm.
Okay. Next, we have this rectangle right here. This big one. How wide is this rectangle? 4 by 3. So what's the area of it? 12. And then I'm going to do this last piece next. From the 7 to the 8. How tall is this one? 3 times 1 is 3. So everybody see how we got the areas that we do currently have. Now I left this one for last because it is the hardest. This is a semicircle negative, okay? It's basically where we have a rectangle, and then we cut a piece of a semicircle out of that rectangle. Does everybody see that? So if I were to enclose this right here, do you see how this actually is a rectangle with a semicircle taken out of it? So how could we mathematically find that area of the shaded region? Yeah, go ahead.
You could do the area of the rectangle, and you could do like the area of a circle, but just cut that in half and then subtract the area of half a circle from the rectangle.
Exactly. Yeah, so anybody on the video who didn't hear that, because it's probably hard to hear, we find the area of the rectangle here, and then we can subtract away the area of the semicircle. So, in order to do that, we have to find the area of this rectangle as if it was a whole rectangle. And what would that area be? 12, right? Because 3 times 4. No, you're good. Does everybody see why it's 12? Just like this other one. And then I need to subtract away the area of the semicircle. Now I know that area of a semicircle is equal to pi r squared over 2, right? What would be the radius of this semicircle? 2. Everybody see the radius is 2. So that's going to be pi 2 squared minus 2, which ultimately would give me 12 minus 2 pi, right? Now I'm going to leave it in terms of pi. If the question says to give an exact answer or terms of pi, you're going to leave it with pi. If it says decimal, put it all in the calculator. Now that we have all of that, what we're going to do is we're going to actually solve the integral using all of these. So I have negative 3 plus negative 6 plus negative 3 halves plus positive 3 halves plus 12 minus 2 pi plus 3, right? That'd be the total area. Everybody agree with that?
Okay.
So from here, what I'm going to do is I'm going to look for things I can just cancel out. So the 3's and the negative 3 halves and the 3 halves, right? And then from here I can just combine. So we got a 24 minus 6, which is what? 18. And then minus the 2 pi because can't do anything with that. So that would have been what the integral is if you were to have evaluated it. Everybody see how we got that? Okay. Now this is the kind of question I would certainly ask on a quiz or test. You know you have one coming up either Tuesday or Wednesday of next week. So yeah, that's that. You feel like you could all do this on your own?
Yeah.
Okay, I don't think it's too bad. It's like geometry. Okay. All right. So here's where the calculator portion comes in. Now I just want to mention, again, all of the integrals that you will have on a test or quiz can be done without a calculator. The two methods we have learned so far are to take the antiderivative and plug in the endpoints and subtract, right? Or we can find the area under the curve by doing a sketch. So here's what we are going to do today to use the graphing calculator. So why would I use the graphing calculator on this question as opposed to taking the antiderivative? It'd be easier, but did anybody in here, except maybe me, know how to take the antiderivative of x times sine of x?
I do.
You only, unless you've learned on your own time, which you may have, I don't know, you don't know how to take the antiderivative of anything that's a product, right? Unless you can just distribute it out and make it become addition or subtraction. Because to take the derivative of this, you would use something called the product rule. And over here, you would use something called the chain rule, right? To take the derivative of these things, because it has an exponent, power. You don't know how to undo those things yet. That's a more advanced skill. We probably won't ever get to it in this class. Unfortunately, I wish we had more time. We totally could.
Thank God.
So, with that being said, we're going to use the calculator. So, that's a lot of talking. So, turn on your calculator. And I want you to go to the button that says math on it. Oh, before we do that, one more thing. You know how the calculators have degree and radian mode? It will matter on this question. I didn't specify which one you have to use, and this doesn't say if the intervals, you don't know if they're radian or degree. So you can use either one. You're going to get two different answers if you're in degree or radian. I am going to do it in degree mode, just so you know. So it's 2 in radians, yep. Exactly. You're right. So if you go to the math button and you go to number 9 on the list and hit enter, do you see how it has an integral on there where you can type in all the stuff? Does everybody remember how to type in x in? You use the xt theta n button. So go ahead and type in those endpoints on there and see if you can figure out the integral. Yep. It is really cool. And don't forget dx. You got to put dx instead of, because it has to know what variable we're talking about. And then
0, 5, 2, 3, 5, 4, 0, 2, 9, 6.
yes, it is. Thank you. So I get 0.0524. I rounded it to the nearest 10 thousandths place. I don't know why. And this one over here, bless you, you're going to do the same thing. Go to math and go to number 9. Now, the reason I also want to show you this, I just think it's really cool how basically what the calculator is doing to get this so fast. You know all those Riemann sums you guys did with the 4 little triangles or the 4 little rectangles or the trapezoids? This calculator is doing infinitely many of them. It's doing like 300,000 of those in a second, which is really, really cool. So the next one is going to be point 886. So there is like a whole math class at some colleges all about like how the calculator does the calculations it does and like programming calculators, which I did take, and it was really, really hard, honestly. But it's really cool because you learn about like how it does these large calculations in such an efficient time, and it talks about like when it times out and like how we've advanced it. So I don't know, I just think it's really cool. So here's some tips for your homework before you get it.